All right, so now we're going to look at one applications of line integral. So for this particular example, we want to find the mass of a wire that lies along this curve R of t that is described as a space curve. As you can see, there's no I component, there's a j and a k component. From t equals 0 to 2, if the density function is given to be delta, that is equal to 3 over 2t. So we know that mass is defined as so let's call it mass is going to be the line integral along the curve C of the density function times ds, where ds is the magnitude of r prime of t dt. That's what ds is going to be. So let's go ahead and find them. So this is our expression for ds. So first thing we need to do is compute the derivative of r of t. Since it's already parameterized for us, we just take that and work on it. So our r of t, I'm going to write it as a vector form. So the I component is 0, the j component is t squared minus 2, and the k component is 2t. That means r prime of t is equal to, take the derivative component-wise, the derivative of 0 respect to t, that's going to be 0. Derivative of t squared minus 2, that's 2t. And the derivative of 2t respect to t, that's 2. And now we take the magnitude of the derivative, that's going to be the square root of each component square, and you add them up. So 0 squared, that's going to be 0. 2t squared, that's 4t squared, plus 2 squared, that's going to be 4. Here you can play around with this a little bit. So you have the square root of 4 times t squared plus 1. And then we can simplify. This is 2, a square root of t squared plus 1. So that is our expression for r prime of t, the magnitude of it. So that means our integral is now going to look like this. So we have the integral along the curve C. So this can be written as the integral from 0 to 2, because that's what we're given right here, t values. The density, which is again given to us, we're going to substitute. This would be 3 over 2t times ds, and ds is r prime of t, the magnitude of it, times dt. So this is 2 times the square root of t squared plus 1 dt. All right, so once we have finished making the substitution, let's integrate now. So here you can simplify the 2 and the 2. So this is equivalent to the integral of 3t, the square root of t squared plus 1 dt. And the 3, we can pull it outside the integral. So this is going to give us the integral of 3 times the integral from 0 to 2 of t times the square root of t squared plus 1 dt. So to perform the integration, we will have to do the u substitution. So we're going to let u to be the following. Let's pick u to be just t squared plus 1. So I'm letting u to be just this portion. So that means du, it's going to be 2t dt. And we already have a t and a dt, so we just need to divide by 2. So that means this integral, we're going to treat it as an indefinite. So we're going to have this is 3 over 2, the integral, treated as an indefinite one. We have the square root of u times du. So what I did here is I divided by 2, so I know 1/2 du is equivalent to t dt. That's what I did. And I also pulled a half out from the integral. Now let's finish up the integration. So this is 3 over 2 times, you can write this as a u to the power of 1/2 and then use the power rule of integration. So this will be u to the power of 3 over 2 divided by 3 over 2, which is same thing as multiplying by 2 over 3. And then plus c, of course. Now, since I'm going to plug in what u is, I'll bring in the limit of integration in terms of t. So you'll have, so 3 over 2 and 2 over 3, they cancel each other. So you're just going to have t squared plus 1 to the power of t over 2 evaluated from 0 to 1. So I finally substituted what u is in here. And now we can evaluate this from 0 to 2. So then we plug in the upper limit, 2 first. So this will give us 2 squared. That's going to be 4 plus 1, that's 5 to the power of 3 over 2. And then when you plug in 0, you're going to get minus 1 to the power of 3 over 2. That's just 1. And if you want, you can leave it right here. This is our value of this mass of the wire. Or if you want to simplify, you can also rewrite. So this is simply square root of 5 cubed minus 1. And 5 cubed, we know we can also write that as 5 times 5 times 5, which is 125, or 25 times 5 minus 1. If you take the square root of 25, that's 5. So 5 square root of 5 minus 1. This would be another way you can write the same answer. All right, I hope this makes sense. Take care, guys.